When working with overhead electrical metallic tubing or EMT installations, selecting the right box and installation method is crucial for efficiency and compliance with local codes. Several options are available, including specialized boxes designed for this purpose and alternative techniques using standard components. Firstly, consider the 4x4 square box with an extension ring that protrudes 1.5 inches outside the wall. This type of box typically features knockouts on all 4 sides, which facilitates easy piping and flexible conduit routing. Secondly, investigate the 4x4 square box with an adjustable extension, allowing for adjustments from 1.75 inches to 3.25 inches. These boxes are generally compatible with both EMT and intermediate metal conduit or IMC, providing versatility in your installation. Thirdly, explore the 2x4 rectangular box with an adjustable extension ranging from 2.18 inches to 4.18 inches. These boxes usually have knockouts on the front and sides, offering convenience for wiring and device mounting. Moving on to alternative methods, consider the offset stub-out technique. This involves stubbing out a short length of EMT horizontally from the wall. An offset box can then be used to connect the vertical conduit to the horizontal stub. This approach allows you to slide the box over the stub, eliminating the need for a 90-degree bend inside the box, which can save time and reduce strain on the conduit. Another option is to install an elbow box inside the wall. This type of box has a knockout on the front for mounting the device and a knockout on the back for the conduit, thus eliminating the need for a 90-degree bend inside the box. This can simplify the installation process and improve the overall appearance of the wiring. When choosing a box or installation method, carefully consider the specific requirements of your project, including the size and type of conduit being used, the depth of the wall, and the location of the device being mounted. Always refer to the manufacturer's specifications and local building codes to ensure that your installation is safe and compliant. Additionally, be mindful of the working space requirements around electrical equipment, as specified in the National Electrical Code, or NEC. For example, NEC Section 110.26 addresses the space around electrical equipment. Ensure adequate clearance for access and maintenance. When running EMT, proper bending and support techniques are essential. Use a conduit bender to create smooth, consistent bends without damaging the conduit. Support the conduit at intervals specified by the NEC, typically every 10 feet for straight runs and within 3 feet of each box or fitting. Use appropriate straps or hangers to secure the conduit to the building structure. Pay attention to the grounding and bonding requirements for EMT systems. Properly ground the conduit to prevent electrical shock hazards. Use grounding bushings and bonding jumpers to ensure a continuous electrical path. Refer to NEC Article 250 for detailed grounding and bonding requirements. When connecting EMT to boxes and fittings, use appropriate connectors and couplings. Ensure that all connections are tight and secure to prevent loosening or separation. Use locknuts and bushings to protect the conductors from abrasion. Consider using weatherproof boxes and fittings in damp or wet locations to prevent corrosion and electrical hazards. Select boxes and fittings that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all, to ensure that they meet safety standards. When pulling wires through EMT, use a lubricant to reduce friction and prevent damage to the insulation. Avoid overfilling the conduit with wires, as this can cause overheating and insulation breakdown. Refer to NEC Chapter 9 for conduit fill requirements. When installing electrical boxes, ensure that they are securely mounted to the wall or ceiling. Use appropriate screws or anchors to support the weight of the box and the devices it will contain. Avoid installing boxes in locations where they are subject to physical damage or excessive moisture. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. To energize the circuit before working on any electrical components, use a voltage tester to verify that the circuit is energized. If you are not qualified to perform electrical work, hire a licensed electrician. Keep in mind that electrical codes and regulations can vary depending on your location. Consult with your local building department or a qualified electrical inspector to ensure that your installation meets all applicable requirements. Understanding the NEC is crucial for safe electrical installations. For example, Article 300 covers wiring methods, and Article 314 covers outlet boxes, conduit bodies and pull boxes. Furthermore, be aware of the different types of EMT fittings available. Compression fittings provide a secure, watertight connection, while set screw fittings are a more economical option. Choose the appropriate fitting based on the specific application and environmental conditions. Also, consider the use of insulated throat connectors to protect conductors from sharp edges inside the box. This is especially important when pulling wires through metal boxes. In addition to the boxes mentioned earlier, there are also specialized boxes designed for specific applications, such as fire-rated boxes and explosion-proof boxes. Use these boxes in areas where fire resistance or explosion protection is required. When installing EMT in concrete, use concrete-tight fittings to prevent moisture from entering the conduit. Also, consider using rigid metal conduit or RMC in areas where the conduit is subject to physical damage. Remember to properly ream the cut ends of the EMT to remove any burrs or sharp edges that could damage the conductors. Use a reaming tool or a file to smooth the edges. When making bends in EMT, avoid kinking or flattening the conduit. Use a conduit bender designed for the size of EMT being used. Make sure the bends meet the minimum bending radius specified in the NEC. Use pull boxes or junction boxes to break up long conduit runs and make it easier to pull wires. These boxes should be accessible for future maintenance and modifications. When installing EMT in a suspended ceiling, use appropriate supports to secure the conduit to the ceiling grid. Avoid overloading the ceiling grid with excessive weight. Use cable ties or straps to bundle the wires inside the boxes to keep them organized and prevent them from being damaged. Label all circuits and boxes clearly to make it easier to identify and troubleshoot problems in the future. When working with electrical systems, always double-check your work to ensure that everything is installed correctly and safely. Use a multimeter to test the continuity and voltage of the circuits. Consult with a qualified electrician if you have any questions or concerns. The NEC provides tables for determining the allowable ampacity of conductors based on their size, insulation type, and installation conditions. For example, Table 310.16 provides ampacity ratings for conductors in raceways or cables. Always use the correct size conductor for the load it will be carrying to prevent overheating and fire hazards. Also, the NEC specifies the minimum size of conductors that can be used for different applications. For example, Section 310.14 specifies the minimum size of conductors for general wiring. When installing EMT in corrosive environments, use galvanized or stainless steel conduit to prevent corrosion. Also, consider using corrosion-resistant boxes and fittings. Remember to properly torque all connections to ensure that they are tight and secure. Use a torque wrench to apply the correct amount of torque to the connectors and fittings. When installing EMT in areas with high levels of electromagnetic interference, consider using shielded conduit to reduce interference. Also, consider using shielded cables and connectors. Always follow the manufacturer's instructions when installing electrical equipment. This will help to ensure that the equipment is installed correctly and safely. When working with electrical systems, always be aware of the potential hazards and take steps to protect yourself and others from harm. Electricity can be dangerous if it is not handled properly. The NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory. This ensures that the equipment has been tested and meets safety standards. When selecting electrical equipment, look for the UL listing mark or other recognized testing laboratory mark. Also, the NEC requires that all electrical work be performed by qualified individuals. This means that the individuals must have the necessary training and experience to perform the work safely and correctly. If you are not qualified to perform electrical work, hire a licensed electrician. The NEC is updated every 3 years to reflect changes in technology and safety standards. It is important to stay up to date on the latest version of the NEC to ensure that your electrical installations are safe and compliant. Consider attending electrical training courses and seminars to learn about the latest changes to the NEC. Also, consider joining professional electrical organizations to stay informed about industry news and trends. When working with electrical systems, always remember that safety is the top priority. Take the time to plan your work carefully and follow all safety procedures. Electricity can be a valuable resource, but it can also be dangerous if it is not handled properly. By following these guidelines, you can help to ensure that your EMT installations are safe, efficient, and code compliant. Always consult the latest edition of the National Electrical Code and local building codes for specific requirements in your area. It is essential to maintain a clear understanding of these codes to ensure that all installations meet the required safety standards. Remember, proper planning, correct materials, and skilled workmanship are key to a successful and safe EMT installation.